Hello everyone, welcome to Flip-Flop Data. This video is in continuation of the earlier video on hypothesis testing and is part of the playlist. Please do watch the earlier videos so that you don't miss the concepts. I have provided the links in the description box and also popped up the same in my video at the end. Also, please subscribe and press the bell icon for notifications so that you don't miss on any updates. If you like my videos, please share it with your friends, colleagues and others. So in the last video, I had covered critical region and critical value. And in this video, I will elaborate on types of errors which we encounter in hypothesis testing in detail. So let's see those errors. So there are two types of errors in hypothesis testing. First is type 1 error and second type 2 errors. So let me give some context to it. In our earlier video of critical region and critical value, we discussed a rule that if the value of test statistic falls in the rejection or critical region, then we reject the null hypothesis, and if it falls in the non-rejection region, then we do not reject the null hypothesis. A test statistic is calculated on the basis of observed sample observations and converting them into a z-score. How this score is computed, I will show that in another video where I will discuss p-value. So, but a sample is basically a small part of the population about which decision is to be taken. A random sample may or may not be a good representative of the population. So a faulty sample misleads the inference or our conclusion relating to null hypothesis. So this gives rise to two types of errors which we can commit while testing a hypothesis. So these are type 1 error and type 2 error. So first we will take up type 1 error. So how do we define type 1 error? So the decision relating to rejection of null hypothesis H0 when actually it is true is called type 1 error. The probability of committing type 1 error is called size of test, which is denoted by alpha, and it is given by alpha equals probability of rejecting H0 when H0 is true. Then what is 1 minus alpha? 1 minus alpha is the probability of correct decision, which is given by probability of not rejecting H0 when H0 is true, or probability of accepting H0 when H0 is true. So one important point to note here is the probability of committing a type 1 error is equal to the probability that this random value will fall within the critical region or rejection region when the null hypothesis is true. Hence, this probability is called as the size of the test or level of significance of the test. Hence, all these terms, the critical region, type 1 error, and level of significance are interrelated. I will define level of significance further in this video. Now coming to type 2 errors. So decision relating to non-rejection of null hypothesis H0 when it is actually false, that is H1 is true, is called as type 2 error. So the probability of committing type 2 error is generally denoted by beta, and it is given by beta equals probability of not rejecting H0 when H0 is false. which is also equal to not rejecting H0 when H1 is true. So what is 1 minus beta? 1 minus beta is probability of rejecting H0 when H1 is true. And it is the probability of correct decision, and it is also known as power of the test, since it indicates the ability or power of the test to recognize correctly that the null hypothesis is false. Therefore, we wish a test that yields a larger power. So let me explain both errors with an example. So take a situation where a person is suffering from high fever and visits a doctor. So the doctor formulates the null and alternative hypothesis as H0, the person is a malaria patient, and H1, the person is not a malaria patient. So the following cases arise. Case 1. The hypothesis H0 is true. That is, the person actually is a malaria patient, and after examination, the doctor rejects H0, that is, declares person as non-malaria patient. It is not a correct decision, and she commits an error in decision making, which is known as type 1 error. So this is false positive case. Case 2. Hypothesis H0 is actually true. That is, person actually is a malaria patient, and after examination, the doctor does not reject H0, that is, declares person as a malaria patient. It is a correct decision, and this corresponds to true positive. Then comes case 3. Hypothesis H0 is false here, that is, a person actually is a non-malaria patient, and after observation the doctor rejects H0, that is, declares person as a non-malaria patient. It is also a correct decision, and this is true negative case. Then comes case 4. Hypothesis H0 is actually false, that is, person actually is a non-malaria patient, and after observation the doctor does not reject H0, that is, declares person as a malaria patient. It is not a correct decision, and the doctor commits an error in decision known as type 2 error. So this is false negative case. So this example gives clear depiction of type 1 and type 2 errors. But now we have to see how we can minimize the errors and increase the chances of maximum correct decision. How do we take a decision that which type of error is more serious for us and which is not? So generally we say that a statistical test is ideal if it minimizes the probability of both types of error and maximizes the probability of correct decision. But for fixed sample size, that is alpha and beta, are so interrelated that the decrement in one results into the increment in other. So minimization of both probabilities of type 1 and type 2 errors simultaneously for fixed sample size is not possible without increasing the sample size. Also, both types of errors will be at zero level, that is, no error will be there in the decision if the size of the sample is equal to the population size. But it involves huge cost if population size is very large, and it is not possible in all situations. So depending on the problem at hand, we have to choose the type of error which has to be minimized. So for this, we have to look at a situation. And one more thing, A general rule of thumb which is followed is a very strong control on alpha is necessary. Generally, the type 1 error should be controlled and it should be kept as low as possible. But again, this is not true in every scenario. So for this, we have to look at a situation. Suppose there is a decision making problem where we make an error. If we lose $100, we make type 1 error, and if we lose $1,000, we make type 2 error. In this case, what we do is we try to eliminate the type 2 error because it is more expensive. So in another situation, suppose the police arrests a person whom they suspect is a murderer. The hypothesis is postulated as H0, arrested person is innocent, not murderer. H1, arrested person is a murderer. So the type 1 error in this case is the suspected person who is actually an innocent will be sent to jail when H0 gets rejected, although it is true. And the type 2 error in this case is when arrested person is actually a murderer but released by the police as non-murderer or non-guilty. Now we see that in this case type 1 error is more serious than type 2 error because a murderer may be arrested or punished later on, but sending to jail an innocent person is serious. So in the previous case of revenue loss, type 2 error was more serious, and in case of murder suspect, type 1 error is more serious. So this suggests us that depending on the situation and circumstances, we decide which error has more negative consequences for us and try to minimize that. But as a general rule of thumb, as I had mentioned earlier also, that strong control on alpha, that is type 1 error, is necessary. It should be kept as low as possible. In test procedures, generally we prefix it at a very low level, that is alpha equals maybe 0.05 or 0.01. So now the discussion will go around level of significance, which is also very important concept to understand. So what is significance level and how do we define it? The probability of type 1 error is known as the level of significance of a test. It is also called as the size of the test or size of critical region, and it is denoted by alpha. So generally it is prefixed as 0.05 or 0.01. So the other way to elaborate on level of significance is that it relates to the trueness of the conclusion. If H naught do not reject at level say alpha equals 0.05, then a person will be confident that statement about H naught is true with 95% assurance. But even then it may be false with 5% chance. So there cannot be cent% assurance about trueness of statement made for H naught. The significance level, which is denoted by alpha, defines how much evidence we require to reject H naught, since our initial assumption is H naught being true in favor of H1. So I hope this topic is clear to you all. With this, I conclude this part. Keep watching my videos. I will elaborate p-value in detail in my next video. If you have any queries, please drop it in the comment section. Thank you and don't forget to subscribe.